Hi everyone, Mark Mosimann, NEUROSPEC in Switzerland. Thank you for again tuning in and watching the second part of Auditory Evoked Potentials using the ActiveTwo from BioSemi plus those new electrode sets especially created to do auditory evoked potentials. I will give you a bit of an overview what's on the table and what's going to be happening after this little overview of what we're having on this setup. Our participant today is Philip Mosimann, who is working for NEUROSPEC, and he's going to be the subject today. We're going to perform an auditory evoked potential or an auditory evoked response on Philip today using the Surpass from EMS Austria, which is a dedicated high quality auditory clicker. It can do signs, it can do clicks, it can do bursts, you name it, you can do it. You can program it using their software, which is installed on my ThinkPad X1, which is a really high quality laptop as well. So we're going to use this combination as a first auditory evoked potential. Together with the Surpass, we send the click into this TDH39, which are unshielded headphones, but unshielded is good because we don't want to shield and hide signal. We want to really see what the ActiveTwo can really do. So we're going to use a pair of TDH39s together with the Surpass from EMS. We will then, of course, connect the auditory evoked potential electrodes, these ABR electrodes, which come with an LA, RA and a reference, as I explained in the last video. Together with that, we will use CMS DRL because you have to. These electrodes would typically be in a 32 channel A set. But today we're not going to use the EEG for the reason of showing how the auditory evoked potential creates using these electrodes in combination with the ActiveTwo and the ABR module. We will actually leave out the electrodes today. This is the ActiveTwo system from BioSemi with inbuilt auditory evoked potential board. We will run the system on speed mode 3, which means it runs on high speed. We use 16 kilohertz because we expect a waveform in the first 10 milliseconds. So we really need to crank up the bandwidth, which we can do if we go to speed mode 3, which is a very high running speed mode, and we can acquire 16,000 hertz samples with a bandwidth of 3,200 hertz. The whole EEG or the ABR will stream over the optical output fiber into the new USB receiver. That's probably not what you have in your lab. Yours is going to be beige, same color as the ActiveTwo has. This is the new USB receiver from BioSemi. It's a really snazzy looking device and has some functions. It shows you when it's on, etc. From there on, we're actually going into our Lenovo desktop computer, and on there we have the latest software ActiveTwo 902, which was just released this morning. As I hear, today is the 24th of March 2022, just so we know. And this latest ActiveTwo with a lot of good features, also with the one-shot triggering, is available from biosemi.com, so you can download it today. It's fresh off the press. We will use some accessories and consumables. We will use some cream, which is like grass paste. We're also going to use some alcohol swabs just to clean the site, make sure that's all nice and properly mounted on the head. Once we've run through the Surpass, and as already promised in my prior video that we've done on the overview of auditory evoked potential, we will also run the whole thing with a one-shot triggering using presentation to see what the difference really is. I mean, the price difference is pretty large. This system costs quite a lot of money as opposed to presentation, which can be basically rented on a year, on 2 years, on 3 years for a very little amount of money. but we can still do an auditory evoked potential using presentation, and I will show you how that works in the next session that we do. All right, let's continue. So what I'm going to show you now first is I'm going to run the clicking software, the Auditory Evoked Potential system basically, which is the Surpass. Here is the software. All we need to do is go to AEP. Basically, we can then start the process. And immediately we can hear some click, but I'm going to make it a bit louder so we can all hear it. That's basically what we're going to do. So this click is going to be put on Philip's head, and we will stimulate his ears. At the same time, when the click appears, we have a synchronous, 100% in sync, a trigger output, which is then routed into our USB receiver using an adapter to USB connection, which is a D-sub 37, and automatically we will see then the trigger marks on the ActiveTwo software. So that's our program that will run the stimulation very, very comfortably. We can also, just to show, we can change some setup things on the stimulator. We can choose either a click or a sine or a burst right here. So if we click 250 Hertz, we have a sine stimulation, but we're using a click. Why do we use a click in auditory evoked potential? We want to stimulate the entire cochlea, and the only way that's possible is when we use a lot of harmonics, millions of harmonics, which is a click. So we induce the click into our cochlea via the TDH39 headphone, and that will travel all the way to the brainstem and obviously up to the cortex, but it will release a nice waveform 5, what we expect in the brainstem using this stimulation. Here we can change also whether we want to do rarefaction, which is sucking of the eardrum, or blowing the eardrum. We can also do alternating. This is all part of neurophysiological paradigms, probably not really used for psychologists. We just want to do a auditory evoked potential or an ABR. We can also change the duration. So you can see what I'm trying to say is, with this particular configuration, with the Surpass, we can change the paradigm completely to our likings. And so that's a really worthwhile system to acquire. But as I said, we can do the same thing with presentation. So this is the software that runs the stimulation via the headphones. We have a trigger generator inbuilt that will click and trigger at the exact same time. That trigger is sent to our USB receiver into the input of our USB receiver port, which is a trigger port. We have trigger inputs 16 bits, but we're only using, of course, 1 bit, because all we do is send a marker, and that marker is embedded with our auditory evoked potential. This is the ActiveTwo. Again, this ActiveTwo is fully configured. It has GSR plate, it has ergo, it has everything inbuilt. That leads to a problem that we can no longer have CMS DRL on the front, which we typically know, which you probably have in your system. So if you had a fully configured ActiveTwo with GSR and plate and everything, and you wanted to do auditory evoked potential, you can do, but we need to shift the board inside, and also we need to make sure that we connect the ABR electrodes here, and we use CMS DRL either from the A set, which here is the DRL and the CMS somewhere else, it's over here, or we use an adapter, as I do, which is a SCSI connector basically with 4 wires for CMS DRL, which are these electrodes right here. So these are the ones. And the auditory evoked potential electrodes, or the ABR electrodes, come with a DIN connector, which by the way is also touch proof. So we're not touching any metals, that's very important to know. So we plug this in through the front of the ABR slot, and we can actually screw that on. So this is tightly fastened to the ActiveTwo. The electrodes, again, I've described them in my last video, consist of the left mastoid, the right mastoid, and the reference. Now, having said that, I need to explain something very important. If you did an EEG also with auditory evoked potential, we would use a cap like this. Could be an ML or a large cap, or this is a medium cap now. 64 channels, 64 holders, 1020 labeled. Remember, the reference which we typically could use would be ZZ. However, the ZZ electrode of this electrode set, of a standard ActiveTwo electrode set, cannot be used as a reference for the ABR. However, the reference on the ABR set can be used, this one here, can be used as a reference also to the EEG electrodes. So what we can do is, instead of putting the reference of the ABR on the front, we can remove CZ if we did an EEG and connect the reference of the ABR electrode set into the slot ZZ, which means in BESA or in other analysis program, we can re-reference using the ABR reference, but also for the EEG. If we use CZ as a reference, we can only use that electrode or that channel for the EEG, but not for the ABR. So this is a little bit more flexible if you choose to take the reference and plug it into ZZ and use that as the reference for not only EEG, but also for the ABR. Very important also is to understand the speed mode has to be set to 3. That's the little speed mode wheel on the front. So what we can do is take a little screwdriver, we go into the slot of the switch and make sure to toggle it to the side number 3. 3 means high speed EEG and ABR all as a single acquisition on high speed, 16 kilohertz, but not 16 kilohertz as on 7, but 16 kilohertz, double the speed. You will see the little speed wheel going double as fast as it normally would do on speed mode 7. Here is the ABR electrode set connected to ABR. We use CMS DRL with a SCSI adapter on the first slot, which is the A slot. The whole EEG or ABR signal is then routed through the optical fiber, which should be as far away the USB receiver as the EEG. That's why it's optical, that's why it can be 10 to 15 or even 30 meters long. All the way to our acquisition computer. And when I start here the software, which is 902, now available from the BioSemi's website, we will, first time we started, we will get this. I intentionally did it this way so people can see, aha, what are we going to do now? So because it's the first time we launch it, we need to say more info and then we can run it anyway. It's a protection. So when we start that, we will get this particular window here. We say agree. We know it's only for research. We say continue. We can maximize the whole thing, which is a feature over the last 4 or 5 versions from BioSemi. It will just fit nicely on the screen. Mac does the same. The first thing we need to do is we need to grab a configuration file. Now, I go to configuring and grab any of these files. Typically, if I did a 64 channel EEG, I grab a 64 channel file. If I did a 16 channel EEG, I grab a 16 channel file. If I had 128 channels EEG and I wanted to do an ABR, I choose this file here. However, let me show you something very important. The configuration file has been expanded with features. I will show you what features. If you go to ActiveTwo, you go to configuring, Let's pick a file such as the 64+8. Note, there is no application allocated to this particular config file, which is okay. We double click it, it will ask you what do you want to use. We go more apps and we choose Notepad. We say OK to this and immediately our file will open. Now the configuration file may be explained in one of the manuals that are available from BioSemi or from us. Just to run through this very quickly is we have different chapters. We have a system chapter, we have a label chapter that goes all the way to 256 channels. Then we have a touch-proof section that is all the touch-proof inputs of the ActiveTwo on the front here, called EX inputs. We can, if we wanted, we can rename that. We could call this one M1 and we could call this one M2 if we choose to use mastoids. Now, we're gonna use mastoids, but the mastoid electrodes are not referenced in this particular paradigm, but they're gonna be auditory evoked potential electrodes. So we could leave that as is, EX1, like this. Next, very important is we have another chapter here called selectors. All these switches here can be set in the actual software itself, so we don't need to do anything there. The only two switches important for ABR is this switch here and this switch down here. So the first switch on top here is called ABR location. Now, depending on what EEG system you have, depending on what ActiveTwo system you have, you may have 64 channels or you may have 128 channels. If you have 64 channels, the ABR module could be in the slot somewhere in the middle of the ActiveTwo. I told you last time in the overview video. However, if you have 128 channels, because you're using location 121 to 128, you do not have 128 channels. All you have is 120 channels. So we have to put the board for ABR in the top front slot. That becomes then slot location 1. However, if you had a 64 channel system like myself, the slot level can be set to 0, meaning it's going to be in slot number 121 to 128, or if you had 128 channels, you move it all the way to the back in the slot RPT DC, which is the last slot in the ActiveTwo. You don't need to know that unless you upgrade your system yourself. Okay, so we keep that at 0. And the other switch down here allows you ABR on, means if it's set to 0, it means you have to always toggle it on if you want to do ABR with EEG. But if you put a 1 there, it's automatically set to always on. So we can save this file. Save, we just overwrite the file, that's done. So this time when we go back to ActiveTwo software, and we say about config, we load our config file that we've just changed, this one here, and say OK to this, and that's it. We can switch on the ActiveTwo. The blue light for the CMS DRL will start to blink, and we can press start, and it will work. First time we have to tell it it's okay. We don't need to block anything, so we allow access. The EEG is running, and when we go to ABR, that should also be running right here. We can see the 3 waveforms, the L-mon, the ref, and the R-mon, as I explained last time. But we will talk about that as soon as we start an acquisition. Now let's continue. We are set to wire up Philip. Just one thing, we have determined to actually use the cap because Philip has quite a lot of hair on his head, and just placing an electrode on top, which we typically can do with pin type electrodes, is using actual cap holders. But since he's got a lot of hair on his head, it may not be really good to use the electrodes just by themselves and some cream. So we're going to do a setup which you probably would do in your lab as well. We just whack on the cap, put some gel in, put in the mastoid electrodes, CMS DRL, and we wire it up. That's what we're going to do now. Okay, Philip, you ready?
Yes.
Good. So before we put the cap on, what we typically want to do first is we're going to wire on the ABR electrodes on the mastoids, because once the cap's on, it's a bit tricky to get to these locations. So here we go. We have the ABR electrode. I'm just going to undo the electrodes from the ActiveTwo. Mind you, for the setup itself, it's clear that the USB receiver, the computer and the ActiveTwo shouldn't be located as close as they are right here. But for the sake of this demonstration here, we hope it's not going to induce too much artifacts from that box straight into the ActiveTwo. That's typically why we have a long optical fiber, okay? So just in case somebody complains or decides to complain about my setting up of the ActiveTwo close to the USB receiver, that's typically not done that way, because we have a Faraday cage where typically the ActiveTwo is placed, whereas the USB receiver is far away, 10 meters, 15 meters, even longer away on another room where the acquisition is taking place. All right, now let's connect these ABR electrodes, and the way we do this is we have two for the mastoid that use a single sticker. So I'm going to choose 20 times 5. Of course, you can use 13 times 5 or 20 times 8, whatever you have in your lab there. So make sure the tab goes to the front. Make sure to actually not stick the sticker on the cavity itself, because in the cavity is your electrode itself. So I'm placing these on there. What I will do first is very important. I typically do that. I use a little bit of abrasive paste. I use Avery or any other pastes that are available. So this is a bit of a sandy paste. I just put a little bit on the paper here. And so what I'm going to do is I'm going to cleanse the place I'm going to stick the electrodes. Abrade the skin a little bit, not too much. Because we're still using active electrode, that has to be said. Once the site has been cleansed with some abrasive paste, make sure to use an alcohol swab to actually clean off the sand. Because the problem is these stickers, they fast very well on dry skin, but if the skin is oily, then the stickers won't actually stay there. So I'm going to use an alcohol swab. And I'm just going to cleanse the site. So this will really dry up. Use the other side as well. Like this, very simply done. You can throw that in the little container we have prepared here. So I'm going to use gel. I'm not going to use the cream, because if you don't use a cap, then you might as well use some EC2 paste or this slick paste here, which is exactly the same thing. But if you use a cap and you use gel here, you can't use cream there. They have to be the same. It's the same with the electrode properties, has to be the same. So we put some gel in there, like so. You can hold on to one of these, Philip. So this is the left, we need the right electrode. So we remove the tab and we stick the electrode on the mastoid, like so. We put the other one on the other side, which we just cleansed before. So this is the left auricle or the LA electrode or the mastoid left, and this is the mastoid right. and we're just making sure these electrodes are nicely fastened, so they're really nicely stuck to the head. So we're going to use the cap now for Philip. The M cap is really a cap that fits him well. Make sure to measure the head. Typically, make sure to use the appropriate cap, not too tight, not too loose. These caps are really nice because the holders inside are pretty high, so the cap is really nicely placed on the head. In fact, none of the temporal electrodes would be hanging in the air. This doesn't matter now because we're only doing ABR, not an EEG. Okay, so we put the cap on. Philip, you may assist a little bit. Is that feeling comfortable? Normally we should measure, but if he puts his finger on ZZ, he can say, yes, that's pretty much the top of his head. Is that good? Yep, I think that's pretty good. If you want, you can tighten the straps, not too much. Make sure it's nice and comfortable so we're not getting any muscular artifacts. All right, so we have mounted the mastoids. So all we need to now do is, I'm not going to go to FPZ, although I could do. The ABR would be pretty much the same, but I prefer the CZ location for my brainstem response because that's really heading straight up. So we pick up the waveform 5 beautifully up here. So we're going to use this electrode here, which is called Ref. We're going to fill CZ. Just put some gel in there. Place the electrode. Now you ask me, why didn't you cleanse this side? Bit difficult to cleanse under the hair unless he doesn't want to go out tonight. So we just leave it like this and hope for a good result. So we've mounted all the electrodes except for CMS DRL that are the electrodes for the ground and the common mode sensor, CMS. So we're going to put some gel into CMS. And into DRL. Beautiful. Just put the electrodes in there, like so. Voila. That's it. There is nothing more you can do. If you didn't have a cap, I say it again, mastoids are exactly the same mounted. However, reference, probably better to put on FPZ. If you think you want to do an EEG together with the ABR electrodes, choose Ref rather than CZ. Let CZ hang out, not touching the skin of the subject. Put CMS DRL in the cap. If you don't have a cap, put CMS DRL on the front as well, next to the FPZ electrode, and that gives you equally good responses for ABRs. That's it. So let's see what we can collect. We're ready. Philip is wired up. Stimulation is ready. Again, dedicated Surpass. And over here, our acquisition computer is ready to acquire the data. So let's see what the offsets are. So what we do is we start ActiveTwo version 902. We go to full screen mode because that's just beautiful. We can fill the whole screen. We go to About Configure. We load our 64 channel file because that's the configuration we've changed before. We go OK and we switch on the ActiveTwo. Philip, would you do that, please? And before we set up the headphones to make him even more uncomfortable, because cap is a little bit tight, but with the headphones it might be a little bit more tight. You can also use, of course, ER1, 2 or 3 headphones from Etymotic Research. You can buy them from us, of course. They're in our shop available. They're a bit more comfortable. The problem there is we have a tube, and the tube length delays the sound by 0.9 milliseconds. That's something you need to compensate from your ABR later on when you do the analysis. This is not the same with the headphones because the coil sits straight on your ears. So let's see the offsets on our ActiveTwo. So I've started ActiveTwo software, I've loaded the config file, it says it right here, so the 64+8 we've chosen because the ABR settings are correct. We press start. Immediately we can see the EEG scrolling across the screen. Obviously there's no EEG because there's no EEG electrodes, but what we do see is we see that the CMS electrode and the DRL are set up on the head. That's why we get a blue light up here. If I unplug the CMS DRL, it will just go off, it won't be blue. If we switch it back on again, we get a blue light, and also probably on the ActiveTwo the blue light is on, which is good, indicating CMS DRL are in range. Now let's head over to the ABR button, because in ABR we can see the actual offsets. Now the electrodes for the ABRs are not connected, obviously. That's why we don't see any low offsets. So let's connect them up to the system. And we can screw that on to fasten it a bit, so like so. The blue light's still on, CMS is still in range. However, over here we can now see that the offsets for all the three electrodes, that's the L-mon, that's the left mastoid, the reference. On top of the head we use the socket CZ, and the right mastoid are in range. In fact, if we look at the EEG from those three electrodes, it looks pretty good. Now, here we have a switch. We can toggle between raw unreferenced, LF referenced, or high frequency referenced. That means raw unreferenced means we're looking at every electrode in reference to no electrode, respectively CMS. That's why it looks pretty noisy. If we reconnect to LF reference, that means we have a low pass and a high pass full bandwidth. Even though we got a click, we can unclick that to actually get the full bandwidth, which this would be showing. And the reference now is towards the reference electrode. That's why it disappeared from the screen. If we switch over to my preferred mode, which is HF reference, that means we are now having a bandwidth, a limited bandwidth of 100 Hz to 3 kHz, which is typically used for ABRs. And the reference is ZZ's reference electrode, which is in the holder CZ. So that's what we're looking at now. Not much of a special screen which we can really use. I mean, we can see that the EEG is not all over the place. We can see the offsets are okay. They're pretty much in range. Now you may ask yourself, yeah, but wait a second, this one is a bit lower, that's the reference, than these two guys here. That's possible because that's on the head and these are on the mastoids. So give and take, I think the range is pretty good. If we now go to ERP, all we're waiting for is the stimulation start of the Surpass, the trigger input into the USB receiver box, and then we can actually see the data coming up on the screen. All right, so let's get Philip connected with the headphones, and we can take them from there and start the acquisition. These headphones are TDH39 headphones. They're not shielded, but that's good because we want to see what the performance of the EEG is, of the ActiveTwo. We have a blue and a red connection. Obviously, blue is left and red is right. So we stick those headphones on his head, like so. Make sure to cover the ears. Now he wants to probably do it himself, unless it's okay this way. Is it good? You feel comfortable? Yeah. Yep, good. So Philip is set up. Make sure to you can make sure not to break off the reference electrode because these headphones are a bit sturdy. So we have to either go and put it underneath. I probably put it underneath because then that sits really nicely on the head. CMS DRL are in range. The blue light's still on. I think from an acquisition point of view, we are ready to roll. So let's come back to the Surpass. In the Surpass, we've already started the stimulation program. All we need to do is set the level of how we're gonna stimulate. I choose 79 decibel normal hearing level. That's not the same as sound pressure level. Normal hearing level is a bit different. Also what we have, we mask the other ear. So we're actually stimulating 80 decibel on the left, and on the right ear, on the contralateral ear, we use a masking 30 decibels less than 80. So we stimulate the right ear with a white noise of 50 decibel normal hearing level, and the left ear is stimulated with a click at 79, respectively 80 decibel normal hearing level. All right, so we're ready to go. Okay, so we've started the acquisition, we're saving the file. Let's come over here to the stimulus apparatus and start the actual stimulation. As we can see on the screen, currently in the trigger window, we do not see any trigger marks because we haven't started the actual stimulation yet. The acquisition's going, we're saving the file, the EEG looks pretty good, CMS is in range, we're ready to go. Philip, please close your eyes, relax. If you fall asleep, it's perfect. Let's start the actual stimulation. When we look over there at the acquisition screen, we can see the triggers are coming in, and now the actual stimulation should start. Can we hear a click in his headphone? Yes, that's good, it's going. So I should be a little bit more quiet now. So what's happening is we're stimulating the left ear with an 80 decibel normal hearing level stimulus, click. And we're stimulating the right ear, the contralateral ear with a masking noise, which is 30 dB less loud than the 80 decibel that we're stimulating. This is running, we don't need to worry about this side. We're coming over here. We're saving the file. We're getting trigger marks 1. Why 1? Because it's brown. If you want to see what the actual code is, you can switch to decimal and you can see 11111. 0 is when, of course, the trigger goes back to 0. So we go back to analog. I like this display. I can see immediately there is a single trigger coming in, and that single trigger will be our marker where we start to average around that trigger mark when we finished. So let's go back to ABR. I explained that again. In raw unreferenced, we're looking at the actual data, full bandwidth in reference to no electrode except to CMS, which is not actually a channel. If we switch over to LF referenced, we're looking at 2 electrodes referenced to the ref electrode at the top of his head, not CMS. Still with a full bandwidth. If we switch over to HF referenced, we're looking at two traces, which is the left electrode and the right electrode reference to ref. That's one of those 3 electrodes on the ABR set with a bandwidth of, and it's grayed out so we can see 3.3 to 100 Hertz. So 3,300 Hertz to 100 Hertz bandwidth. This screen doesn't give us much, except we can see the offsets. The gel has actually worked itself into the skin a little bit. That's why they're all about the same size, which is fantastic. So let's go to ERP and let's choose trigger 1 and let's start an average. Let's see what happens now. Mind you though, I had set the sweep length at 12 milliseconds. So from here to here it's 12 milliseconds now. And mind you, we're not looking at EEG as to speak, we're looking at an average building up. Now, if this was a Faraday cage and it was a good environment, the gray waveform behind the colored waveform is actually our noise level. And over time, the noise will average out because it's not in time or it's not time locked. Whereas the colored waveforms where we can also see the stimulus artifact on the left ear, because blue is left and red is right, is the stimulus artifacts beautifully visible, and the noise is slowly getting phased out, slowly getting to zero. If the noise level is practically at zero, we can basically stop averaging the data. Let's play a little bit. We can change the scale. Here it's to 1. We can change it to auto scale, or we can change it to manual scale. If I put 0.8 in there, it's a little bit bigger. We can actually go to about 0.5, which would be a really nice sort of size. Now, having said all that, we can already see the stimulus artifact. We can see waveform 1, 2, 3, 4, and probably around here is around 5 is growing out of it. So it's really nice because we have here a time scale of 12. So waveform 5 should be around here, working itself up over time. This is our contralateral ear. There we can really only see waveform 5 really nicely coming out here. So that would be waveform 5 growing up to here. And this is the contralateral ear with not much responses from 1 to 3 to 4, because we're talking about the contralateral ear with a masking noise to avoid bone conduction. If there was a problem, otosclerosis, where we can get a bone conduction on the other ear, that's why we mask it with a white noise. So this is beautifully acquiring the data. As soon as the gray waveform has flattened a bit more, we can stop the actual acquisition, but let it run for probably another 1 minute and then break that off. So we're back after doing an acquisition with the Surpass and very precise triggering. We're going to look into how we're going to do that using presentation with one-shot triggering and the config file that actually has to support that. So what we do is we're going first to the presentation computer, and I've already launched a paradigm called Click Scenario. It's an experiment, and when I look at the experiment itself, I can see that we're using an interstimulus interval of 89, which is about 11.2 stimuli per second. We're letting that run for 2000, and it's a WAV file probably around 70-80 decibel. But again, without appropriate software and hardware, we can only provide a click, which we hope is in the same order of loudness as the one that we've presented with the Surpass. All right, so that's good. That's actually waiting for us to start. Philip being very relaxed over there with the cap still on the head. Earphones plugged in. However, we're not using the TDH39. We're using some standard headphones, which we plug into the ear, so the inner ear headphones, not tubal inserts, so we don't have a delay issue. We have the ABR electrode and the CMS DRL still the same, connected. We do hope that, of course, the offsets are still fine. This time, however, I'm actually connecting an MMB trigger box, not for triggers, but just to get no triggers, respectively no colors at all, because they're actually shutting down all the channels, all the 8 lines. So we only see the actual triggers coming through. Now, we already see in ActiveTwo that we've started it before just to make sure it's all running. But what are we doing now? Okay, so let's have a look at the configuration we're using this time. In order to do one-shot ergo triggering, we must have an optical isolation. This is the optical ergo input adapter we can purchase from here or from BioSemi. So basically what that does is the output of the laptop is going into an optical isolator from BioSemi. We're feeding the signal into here and connecting this to a mains adapter. That's okay, because the output is completely isolated and we're using a plastic fiber instead of a glass fiber. Similar thing, we can't do it as long as we want, probably maximum length 10 to 15 meters. So we're running this over this is an optical fiber, plastic, into the ActiveTwo using an ergo input connector. Philip, would you like to connect that? So that's connected. So basically what we're doing, we're sending the stimulus onto the headphones, and the actual stimulus output, not the trigger out. This is not needed. It's just for makeup, so we don't see the other 8 lines. The trigger is actually split between the headphones, which we connect using this connector. That's the headphone connector. So we connect that to the line out of the headphones, and we split the output, because we have a left and the right ear. We split the output into our ergo adapter, providing the trigger, but not via the trigger input on the USB receiver, but through the ergo input on the ActiveTwo. A few configurations have to be considered if we want to go this route. We open again the config file that we had opened before. And this time we have to look at this particular settings right here. The trigger length, the trigger level, the trigger window, and the trigger polarity have to be set correctly. However, before we change any of these settings, make sure to notice that there is an option called RESP switch, which is response switch. And it's really nicely explained. If we set a 0, we have an ergo input, but no coupled trigger on the bottom. So when I look back at ActiveTwo software, I would see the ergo response, but I would not get any triggers at all. This is when the RESP switch is set to 0. If the RESP switch setting is set to 1, however, then we couple the trigger lines 9 and 10 on the USB receiver, because we have 16 inputs. The first 1 to 8 inputs are for presentation, E prime, psychopi, you name it. 8 bits out, 8 bits in through 1 to 8. 9, 10, 11 and 12 are coupled to a RESP switch setting at 1. However, there is a new setting, and it's number 3. If I set it to 3, we can then do one-shot triggering. That means we're using the ergo input and an output via this optical isolator as our trigger line. This is wonderful because we can then escape the first 8 bits, go to the 9th bit and expect a trigger input which is exactly at the same time as the line output for the headphones. So we've set this to number 3, which is good. So we can save this. Also, we need to remember the trigger length, the trigger level, the window and the polarity. Bit complicated, but it's really essentially quite easy. So what are we doing? We're triggering 11 stimuli per second. So that gives us a trigger length of about 80 millisecond delay between the 11 stimuli. So I set this to about 8 milliseconds. It doesn't really matter. We could set it to 100 or to 80 or something. The trigger level is in millivolt. Since we're using a line output, we're pretty low with the amplitude coming out of this thing. Could be anything between 100 and 100 millivolts to 2 volts. So I set this to around 100 millivolts. So we're getting an actual trigger. If I set this to 2000, which means 2 volts, I probably wouldn't get anything because that level is pretty low. Depending, of course, also on the the sound output. The higher the noise, the higher the level. But because we're stimulating with a reasonable sound output, I would set this to around 100 millivolts. The trigger window doesn't really matter. We leave that at the level. So as soon as it exceeds a level, it will then look at what comes in. And the polarity, I'll leave that to 1. That means it triggers on a positive upgoing level. Once you've set all this to about these settings, it's a little bit, you have to play with these settings a little bit, but it's more or less self-explanatory. So we say File, Save, we can close this window, and we can go to ActiveTwo, and we open this configuration file that we've just done, which is this one here. I've changed to 32+8, not the 64+8 like before, and we say OK. We agree to that. We can say don't want to show this again, and we press continue. Philip, please switch on the ActiveTwo. And let's make sure the triggering is working before we start the recording. So we go to Start, we go to Sensors, we click on Ergo 1 only, we click on about 50 millivolts, we click the low pass, we don't see anything. That's okay. We don't see a response, we don't get a trigger. That's fine, because we haven't started presentation yet. Now let's start presentation and see what happens. So we press yes, we run the scenario, we press the button to start. We're getting a sound on Philip's earphones, which is good because we're splitting the output. So over here we're getting the ergo response, which is the trigger, the click. And on the bottom, we're getting the corresponding trigger in line with the actual click that we're presenting. So let's start the recording. I just stop this quickly again. I say finish. This is now not running. Philip is relaxed. Hope still relaxed. He's got the cap mounted. He's got a pair of headphones on, which are not high quality headphones. They're just some insert headphones for playing music. The ActiveTwo is running. We can see over here it's all set up. So we say Start File. We say again some identification number. We're not recording any channels. We don't record these. ABR is already highlighted, but we can't do anything. That's fine. So we go here. We say what are we going to record? What are we going to name the file? We go to ABR tests. We say Philip ABR 02. And we call it presentation this time. So we say go, and we unpause, and we're coming back to the presentation laptop, Stimulus. Philip, you ready? Close your eyes, last test, then we're going to break it all off, okay? So we press run, we press start, we run the scenario, we press the enter button. Remember, this is running in exclusive mode, very, very important. Exclusive mode means the whole hardware, everything, presentation takes control of the sound card and putting out the sound in basically real time to what we're seeing on the screen. We're coming over here, we can see the stimulation has started. We're getting beautifully the triggers on the bottom. We're getting the ergo response according to the click. This is the click sound we're looking at. Now let's go to ABR. Let's go back to HF referenced signal. That looks a little bit different than before because I think the electrode's been on the head for a pretty long time. That's okay. So we're looking at that. Now, what we want to see is the ERP. Now we click on the ERP button. We can't see anything. Now remember, at the moment we've chosen trigger, we could have chosen trigger 1. That could be still the case. But this brown dot is not on the top, but it's after the 8th bit. That means we have to set it to the bit 9. Because remember, in the config file we set it to response switch equals 3. That means the trigger is actually routed to our 9th bit. So we have to scroll down here a bit, go to number 9 and press start. Now we should be getting a signal, which we are. So we're triggering on the bit number 9. I have it not to auto scale, I have it to 2. We're having a sweep rate of 12 milliseconds, so from here to here is 12 milliseconds. We're starting to get a signal. Let's bump it up to, let's go to auto scale to see what happens there. So that's building up the trace. I can actually remove that and make it a little bit larger. Go to 2. We have a lot of noise, and of course that's due to my setup. I mean, we've got the cables running all over the place. The laptop and the USB receiver box is a bit too close to where he is, but that's okay. Once this is ready and finished, we will analyze it in the next movie using BESA, using also ActiveTwo to compare a little bit what are the different packages that we can make you available. But as far as I'm concerned, this is running. The ABR offsets are okay. In fact, when we look at the signal, all the signals that are available on screen, this looks looks reasonable. It's not. I'd say it's good. It's what we're expecting. And so let's see, we've done probably about 1,000, maybe 2,000 sweeps. We can see here the waveforms building up. I think this should be waveform 5 around here. The filters are set to, they're locked into low pass and high pass, 3 kilohertz and 100 hertz. When we analyze the file, it will look different than what we're looking at the moment on the screen. So I think that actually wraps up the stimulation setup. What are we using? We're using the Surpass, which is a dedicated ABR system. We're using presentation through one-shot triggering using a optical isolator between the laptop and the front end of the ActiveTwo, which is a must. We cannot do it any other way. We cannot just put the ergo response, respectively the sound output, straight into ergo inputs, because that will break the isolation. So in effect, that's the setup we have come to do. We're seeing the noise is being really flattened out, because we're averaging noise, which means it's not time locked, so it will end up as a straight line, whereas our response is nicely seen on the back. When we do the analysis, we will see a much nicer waveform, and we shall compare that to the waveform done with a dedicated Auditory Evoked Potential system. But that will be the next video. So I hope you can now set up your own paradigm in your own lab using the ABR module of the ActiveTwo if you upgraded your system, and you shall have a lot of fun using that, because it's quite simple, and I've given you flexible solutions using a dedicated sound box or an ABR system such as the Surpass, or even just a low-cost solution like presentation. Hope you liked the video. Please subscribe and go on our shop. We have a lot of accessories we can offer. That wraps up our second part of the video. Many thanks for watching. It's been great fun. Thank you, Philip. I think we can stop the actual stimulation and release him from the cap and everything, and let him go home and have a good evening. Well, I wish you all the best and see you next time. Thank you.